Hello everyone. Today we will have a session on projection of solids and the topic being freely suspended solids. Now this is the problem statement. A hexagonal pyramid, 25 mm sides of the base and 50 mm axis length is suspended freely from the corner of its base. Draw the projections of the pyramid when the axis appears to be inclined to VP at 45 degrees. Now, whenever a solid is freely suspended, now there will be an imaginary line which will be connecting the center of gravity of the given solid with the point of suspension, and we need to ensure that this imaginary line is perpendicular. So let us go to the problem now. I have got the solid edge window being opened. I have the problem statement. Again, I'll read: the hexagonal pyramid of 25 mm sides of the base and 50 mm axis length is suspended freely from the corner of its base. Draw the projections of the pyramid when the axis appears to be inclined to VP at 45 degrees. Let us start. Let's ensure that the page setup is done. Already it is having A4 sheet being selected. Then we'll go with the creation of the line for the axis, that is the XY line. We'll go with a normal line and ensure that I'll write the annotations using Arial font of 3 mm size. I'll write X, Y, VP and HP. Let me zoom and fix the annotations perfectly. Right, once I fix the XY line, let me lock the XY line so that my drawing will be anchored with respect to the XY line. Alright, now we'll go for the construction of the hexagonal pyramid and I'll keep the hexagonal pyramid on the horizontal plane with its base, and I'll ensure that one of the corner of the base is coming onto either left side or the right side. So because it is a hexagonal pyramid, I have to keep it in the corner condition. So let us go with the corner condition. We'll use the visible line and I'll create hexagonal pyramid top view with one side being horizontal parallel to XY line. I got the hexagon being drawn, rough one. You get the dimension of one of the side. The given dimension is 25 mm, so let me make it as 25. And to make all sides equal, we'll use equal command. Second side equal to first, third side equal to second, fourth equal to third, fifth equal to fourth, and sixth equal to fifth. Then I will go with the angular dimensioning between the any two sides. The angle is 120. I'll give it for another two sides consecutive, so then it will be automatically having all the other angles being made as 120. So once it is done, I have to have the apex, that means the center of the pyramid has to be found. I'll connect the diagonals So I've connected all the diagonals here now. So then let us name the different corners. Let me start with the corner A here, B, then C, D, E and F, and the access points, let us name it as O, the top point, and O1, the bottom point of the axis. Alright, once it is done, let us draw the front view. I'll use the normal line and draw the projectors from all the corners of the base just above the XY line. I'll use the Intel sketch help end of the line and I'll draw vertical projectors, and even from the intersection point. So you'll have to ensure that in the Intel sketch relationship intersection is on. They can have the intersection point, or in this case it can be the midpoint as well. I'll just project that also above the XY line, and I'll trim all the points above. Then let me draw the center line representing the axis from XY line above, and we'll give the dimension. The dimension of the axis or the height of the pyramid is given as 50 mm, so I can make it as 50. I can make it as 50. Then let us mark the various corners, the front views of them. So this is A dash, then you will have B dash, and behind that we'll have F dash. Then here we'll have C dash, bracket E dash, and D dash. These are the base corners. Then you have the apex, that is O dash. Base, you have the axis point, that is O1 dash. I'll keep it inside the bracket because O1 dash is not visible. The base is resting on the horizontal plane, so I'll not be able to see the base. Alright, once this is done, we can have the rule of visibility being employed. The first rule says boundary of any view is visible. So I'll have the boundaries being connected from A dash to B dash F dash to the center point, then C dash E dash, then D dash, O dash, back to A dash. Right? So that's the boundary. Then let us decide the slant edges. So we have 6 slant edges. A dash O dash and D dash O dash have been already connected as a part of the boundary. We'll decide the remaining 4. Out of that, B dash O dash and C dash O dash are very much in front, so that should be visible. So I'll have B dash to O dash and C dash to O dash being connected. Then the rest of the slant edges, that is F dash O dash and E dash O dash, so they are hidden, so they are behind, so they are not going to be made as visible. So now this is the front and top views of the simple pyramid, hexagonal pyramid resting on HP with its base, and I have kept it in the corner condition. Now we'll have to have the pyramid as per the given problem to be suspended freely from a corner of its base. So I can take the corner of the base as either the base corner can be D, or I can have it as A. Okay, so let us say that we are connecting it to D from point of the base, that is corner D dash, we are going to suspend. Now here the point which I was telling earlier is, whenever there is a suspension of a given solid, then what will happen is the mass of the given solid, which is having its center of gravity, and the point of suspension shall be vertical. So I need to have the center of gravity to be connected. Now for a pyramid, the center of gravity will be at a height of h by 4. Okay, the center of gravity will be h by 4, that is height by 4 for a pyramid. For a pyramid and cone. Okay, for a pyramid and a cone, the center of gravity will be at a height of h by 4, whereas it will be equal to, CG will be equal to, the length of the point of CG will be h by 2, that is at the midpoint for prism. Okay, for prism it will be at h by 2, and cylinders, for cylinders and prism it will be h by 2, that is height by 2. So now we'll have the center of gravity to be marked in this problem. From the base it will be at h by 4, from the apex it will be how much, 3 by 4th of h. So h is 50 here, so h by 4 is 12.5. So we'll go with the construction line. From the base, I'll draw one construction point, and let us take this dimension of this and keep it as 12.5, that is h by 4. Now this will be our point G, so I'll call it as G dash. The front view of that will be called as G dash. So we can have a line now from G dash to D dash. Now this is the imaginary line which we were talking about, which is connecting the center of gravity G with the point of suspension, that is D dash. Now this completes the first step. So in the second step, what we are going to do is, we'll have this solid being tilted such a way that the suspension point D dash is at the top, and we'll have G dash D dash being vertical. Okay, so that's the next step. So we'll go with the next command, that is move with a copy, right? Move with a copy. I'll just only select all the lines with the press of control button, or else, okay, we'll go with the window selection, then we'll delete all the annotations, that is easier. So selected all the elements, and from D dash I'm just moving it over here. Okay, so after that let me delete all the annotations, because annotations will be also rotated along with. Alright, so I got the front view being moved now. Before we proceed further, we'll just rotate it without having any step with respect to D dash. I'll rotate it almost downwards, then we'll make it rigid so that all elements will be intact. I'll have this rigid set being selected. When I select rigid set, it is asking click on the elements to add to the set. I'll go with the window selection here. So every element is being selected. Then I will say yes. So now what happened? Just if you try to drag the front view, any line you take, so that will be simply moving as a single unit. So in the next step, what I am supposed to do is the line connecting the center of gravity, that is G dash to D dash, is made vertical, so that the point of suspension is over here. So for that, we'll just select horizontal vertical, and I'll make this line vertical. So it has moved out of frame, but it has become vertical. You can just drag it, and I can move it. Right, the front view after making it vertical has gone up. So let me bring it and keep it wherever you wish, so that now I have the solid being suspended from the corner D dash. So I'll go for the annotations here again. This is A dash, B dash, and F dash. I have a C dash and E dash and D dash. Here is apex O dash and the base of the axis, that is O1 dash. Now this is how it will be, right? So you'll be having the base moving upside and the apex will be downwards. Once it is done up to this stage, the remaining process is as usual to complete. To get the second top view, we'll again go with the drawing the various projectors from the top view and the front view. Let me draw vertical projectors from the front view first, from A dash, B dash, F dash, C dash, E dash, and D dash. Of course, the point G dash is here. Yes, the G dash point is there. And from apex O dash and axis end O1 dash are on the vertical projectors. Next, we'll draw horizontal projector from all the base corners of the top view, that is from A and D, then from B and C, and then from F and E. So we'll trim after naming. We can name them first. A and A dash meet at A here. B and B dash meet at B here. C and C dash meet at C here. D and D dash meet at D here. E and E dash meet at here, E dash, and F and F dash meet at F here. O dash and O meet at O, and O1 from here and O1 dash from here will meet at O1 here. So let us trim the corners. So this is for O. So this is for A here, not required. So it is B here. Then I have C here. D is up to here. Then I'll have E, F, right? So now all the corners have been marked. This is not E dash, it is E. Okay, next is creating the top view, second top view. Rule number 1, visibility rule. Outside of every view is visible, or the boundary is to be visible. So from O, I'll go to C, then D, then A, then for this intersection point F, then intersection point E, then the next point on the boundary is back to O. So boundary has been connected. So I got the boundary of the second top view being made available. Next is the visibility of the base. I'll have to decide the visibility of the base. So for that, since we don't have the real pyramid with us, we can just imagine that the observer is viewing from this end. Now when the observer is viewing from this end, right, the base is nearer to the observer, therefore the base is visible in the top view. So I'll be connecting all the corners of the base with the visible line. So that is from C to D, then D to E. So these are the base corners being connected, base is visible. Now we will have to decide about the slant edges. Now already two slant edges have been connected, that is C to O and E to O have been connected. I have to decide about the remaining. First we will decide about D to O, D dash O dash, which is the nearest slant edge. So in the top view it should be visible. So D to O is connected with the visible line. Then we have F to O, A to O and B to O. So these are the slant edges which are not visible in the top view. So I'll have to go with the line type which is hidden. So from B to O and from F to O, I'll connect it as a hidden line. Next, from A to O, I should have the hidden line. So already I have a construction line here. So let us split this. I'll use split command. So this line I'll first split at O, so that I got O to A. Now again I'll split this at the point D, so that now this is separate and this is separate. So then I can have this line type being changed to hidden, right? Again I'll split this because I want to have axis next. So I can have this being split. Okay, that is not necessary because we have the problem where apparent angle is probably directly given. Otherwise I'll just split the axis point also. So this completes the second set of views wherein I have got the solid being suspended freely from the corner of its base. In the last stage, I have to give apparent angle of 45 degrees for the axis. It is given that axis appears to be inclined to VP at 45 degrees. So it is appears to be, so that means it is apparent angle. So for that, I'll just move copy the top view, select all the top view points I'll keep original here, and with any reference point I'll just move it. Okay, before that I need to split the access point. As I said, O1 is required, so I'll split this at this intersection point. So this has been split at the midpoint or the intersection point, so that I can have that being used to draw projector from O1 in the next view. So let us move, copy the top view here, has been moved here. So then remove the notations, otherwise they'll also get rotated, right? So the next is I'll just have to give initial rotation before I make it rigid. I'll go for initial rotation, reference to O and A, give some initial rotation, there afterwards make it rigid set, select elements, add to rigid set, say yes, so that now it is moving as a single unit. It may move in only perpendicular to the axis directions and parallel to that. Then just I need to give the apparent angle, so I'll give the angular measurement between the axis and XY line. It is 32 degrees. As per the given problem statement, it is 45 degrees. So I'll just make it 45 degrees. It may move up above the XY line, but you can always bring it down. Right. Right. So we'll complete the final view, the final front view. After giving the naming, I'll just name the different coordinates. So here it is A, then B, C, D, E and F, and we have O here and O1 here. In this case O1 is visible here, right? So the next stage is draw projectors from A from B from C then from D from E and F. Similarly from apex O and from O1. Then let us draw the horizontal projectors from A dash. I can draw it till where I require onto the projector from A. From B dash F dash I'll draw up to where it is required for B. Then from C dash E dash where it is required up to C. Then from D dash it is up to project from D. Similarly from O1 dash and from O dash. I need to draw a horizontal line here. Coincidentally, they may be horizontal. Let's trim the different corners. I'll track it from A. So the projector from A dash is here. So I don't require this projector above. So from B it is here. I'll trim this. From C up to here. From D, the maximum point over here. Then from E, it's up to this projector E dash. Then from F, it's over here. It's up to this projector. So I have F here. So I got all these 6 points. 1, 2, 3, 4, 5 and 6. And lastly the access points. I have the access point here. The access point, one point is here with O, it's here, and with O1 and O1 dash it's up to here. So I got all the 6 plus 2 points, so I'll mark them. This is A dash, this is B and B dash meet at B dash. Similarly C and C dash meet at C dash here. D and D dash meet at D dash here. E and E dash meet at E dash here. F and F dash meet at F dash here. Similarly, projector from O and O dash meet at O dash here. Then from O1 and O1 dash it meet at O1 dash here. So I got all the corners being marked now for the final front view. Then we'll draw the final front view with the rule of visibility. The first rule says boundary of every view is visible. So I'll start with the corner A dash to B dash to C dash to D dash to E dash to A dash, rather O dash to A dash, the boundary of the view. Then again we'll decide the visibility of the base now, being the observer from this end. I'll have to decide whether base is nearer to the observer or away from the observer. Since the base is nearer to the vertical plane, it is away from the observer, so it is not going to be visible. So base is going to be hidden. So I'll have to make the base edges being visible, rather hidden, other than the boundary. So from A dash to F dash to E dash, I have the hidden base. Then we'll decide about the slant edges. The nearest slant edge in the top view is C2O. So C2O should be visible. So C dash O dash, that is O dash to C dash, can be visible. Then D dash to O dash is also nearer, so that also should be made as visible. And one more is B dash to O dash, or O dash to B dash, that's also visible. A dash to O dash and E dash to O dash are really part of the boundary. Only thing remaining is F dash to O dash, which is farthest from the observer. So F dash O dash is connected as a hidden line. So from F dash to O dash, you connect it as a hidden line, and F dash should be inside the bracket. So I'll have to make it as parenthesis F dash. Okay, now this is how the problem is solved. Alright, what precaution should be taken while solving the problems on suspended is, whenever the initial position is to be kept, you should ensure that we always start with the corner, one of the corner onto the extreme side, either left or right side. If you keep it in the edge condition, that is edge being perpendicular to XY or VP, then it is not going to be possible to suspend it from a corner, because it is the edge which is visible as a line in the top view and as a point in the front view. So the idea is you should have the corner coming onto one of the side. So this is for pyramid now. Suppose there is a problem, I have a second problem now. A square prism of 35 mm sides of the base and 60 mm axis length is suspended freely from a corner of its base. Draw the projections of the prism and the axis appears to be inclined to VP at 45 degrees. Now in this problem, the initial situation or initial condition what we say is the same. That means the square prism has to be kept in a condition such that the base is resting on HP with one of the corner coming onto the right side. So that is corner condition. Then you locate in the first front view the axis mid height, so which is nothing but the center of gravity G, and connect it to the base corner which is going to be suspended from, and then make that line, imaginary line connecting the center of gravity with that corner vertical in the second front view, and continue the problem. Hope this problem is understood now, and you can try many other problems with the prisms and pyramids, so that this topic is going to be very useful for you in engineering drawing. So thank you so much. We'll meet in the next video with the next topic. Thank you.